very helpful. This file can be very helpful when you are preparing for the final exam. Can you recall this also? Halogens, if you go down the group, melting point, boiling point increases, reactivity decreases. They all are diatomic. The color darkens. Astatine is radioactive, so we do not talk about it. Acha, fluorine is also out of discussion in O level because fluorine is overreactive. Fluorine is overreactive. It does not react in a proper, nice way. Now, Mikhail, can you recall these properties, please?
Done.
So, can you recall them? Can you able to? You have to memorize them. Halogen reactivity. They have a tendency to form salts. They are non-metals. They have a tendency to gain electrons. If you go down the series, reactivity decreases. Look at this. Fluorine has two electron shells. Its nucleus is very capable at attracting electrons from other atoms. This makes fluorine very reactive. Look at this big heavyweight halogen, and look at the 5 electrons in outermost shell. So it is not capable of attracting electrons. So down the group reactivity increases. Down the group reactivity down the group reactivity decreases. Fluorine is the top one. Fluorine is very, very reactive. So I'm putting my first concept of discussion. Down the group, down the group reactivity decrease. Fluorine is the most reactive halogen. Fluorine is the most reactive halogen. Fluorine is the most reactive halogen. We have it, and it is actually, you know what? Actually, fluorine is one of the most reactive element known in the whole world. So fluorine is the most reactive element. So you have to copy this rule. You have to memorize this rule. Fluorine is the most reactive halogen. So halogens are in group 7. So they have 7 electrons. Look at this 2, 7, 2, 8, 7. Halogens are electronegative. So this is my third concept for today. Halogens have a tendency to absorb electrons. Halogens are non-metals, so they react with metals to form salt. Halogen means salt former. To look at the two properties, halogens are electronegative. They have a tendency to gain electron. Halogens have a tendency to form salt. So now you have to copy this screen. I'm just coming in a minute. Please copy down this screen.
Done. done. Done.
Now we have displacement reaction. What's the concept of displacement reaction? Displacement reaction means you replace someone, and these are special reactions of chlorine, bromine. And look at this example, Cl2 plus KBr, KCl plus Br2. Now, how this is a displacement reaction? Chlorine has displaced bromine. Chlorine takes the place of bromine. This is called a displacement reaction. So the rule comes in, more reactive can displace less reactive. For example, chlorine can displace bromine. So give the heading displacement reactions.
You're done.
Right. The rule comes in, more reactive can displace less reactive. And remember, in halogens, down the group, reactivity decreases. I repeat, in halogens, down the group, reactivity decreases. So chlorine is more reactive than bromine. More reactive can displace less reactive. So you have to copy this.
You're done. Now I'm done.
Right. Now, look at the reaction. Cl2 plus KBr gives you 2 KCl plus Br2. Look that chlorine has displaced bromine. You have to copy this. So now, you can see that bromine cannot displace chlorine. Reverse cannot occur because it's a game of reaction. It's a game of reactivity. So different salts can be made. Look at this. Potassium chloride, look at the case, no reaction. Then potassium bromide, no reaction. Remember, more reactive can displace less reactive. More reactive can displace less reactive. Now look at this table, potassium chloride, no reaction with chlorine because it's self-chlorine. No, when adding bromine water, bromine cannot displace, look, no reaction even with water, iodine. Acha, when I add bromine, chlorine displaces it, orange, bromine solution form. And when I put iodide, iodide will be replaced. So you have to remember the format of this. So I will test you by putting this idea that bromine cannot displace chlorine. Why? Because it is more reactive, because chlorine is more reactive. Now look at this reaction. Look at this reaction that KBr plus I2. Do you think this reaction will occur?
Bromine will displace iodine.
So it will be 2Ki. Think about it again.
Wait. Bromine is more reactive.
Good. So bromine is more reactive. So this reaction,
No displacement.
yes, very good. So this reaction is not possible. Acha, I changed the reaction. I put Ki plus Br2. Now, can you tell me if a reaction can occur?
Yes, bromine will displace chlorine.
Look at this. So bromine will come in the solution, and very important is the game of colors.
Wait,
We
what?
have
You wrote it wrong.
hmm,
It's 2KBr.
KBR
Can you
is
go back? Can you go back, please?
sure.
It's 2KBr, right?
2 KB. Huh? Acha. Oh, sorry. Right, very good. So, typing error. It should be so 2 KBR plus I2. This is the reaction occurs. So more reactive can displace less reactive. Now look at this ionic equation. I'm trying to write down the equation to show the ionic change. Now this is the equation. Yes, Mikhail, can you hear me?
Yes.
Now put the charges, the redox.
Yeah.
Put the charges and observe that Br minus is changing +1 to 0, and chlorine is changing 0 to -1. So it means bromine is losing electron. Bromine is losing electron and becoming a neutral atom, while chlorine is gaining electron. Loss of electron, when you say loss of electron, is basically loss of electron. Loss of electron means this part is oxidation, and this is gain of electron. So this part is reduction.
Chlorine got reduced.
It means chlorine is being reduced and bromine is being oxidized. So this is the language to remember. So you will write the language in this way. You will tell in the paper the language that look, Br minus is oxidized to Br, and Cl chlorine is reduced to Cl minus. This is a typical language. Achha, this language is used in reverse order. Something which is a reducing agent will be oxidize itself, and something which is an oxidizing agent will be reduced. It's always used in opposite sense. So you will mention here for your memory that chlorine is a good oxidizing agent. Chlorine is a good oxidizing agent. So now copy this. Have you done it?
1 minute. Oxidizing agent, it means it oxidizes the other, but it undergoes reduction.
Yes, itself it is reduced.
Yeah. Okay, done.
Right. Now we have to mention we have to discuss the ionic equation in some more detail. We have to see again the same equation as a sample. We are going to use the same equation. 2 kBr plus Cl2, 2 KCl plus Br2. Now we notice about K plus. No change in oxidation state. Achha, when there is no change in oxidation state, when there is no change in oxidation state, so
Not change for potassium.
K plus is a, in chemistry we call it spectator ion. K plus is a spectator ion and it can be emitted, in the, it can be emitted in the ionic equation. Look at this. You have to copy this now. Spectator ions are those ions are called spectator ions in chemistry whose oxidation number is not changing. So they are actually the spectator ions here. So what the chemistry says, Mikhail, that you can write the equation without them. So look at the final form, 2Br minus 2Br minus plus Cl20 will give you 2Cl minus plus Br20. This is the ionic equation. This is the ionic equation. So you have to copy this.
Done.
Now we have done halogens and
So if it's a non-ionic equation, you just add 2Br and Cl2, 2Cl and Br2 without the minus and plus.
no, can you repeat the question that what do you mean by that? Like this equation?
It asks for non-ionic, like
Acha, non-ionic equation is the first one, 2 kBr plus Cl2, 2 KCl plus Br2.
okay.
Actually, every equation is by default, every equation is by default, and every equation is by default is called a basic equation, which is non-ionic. Ionic equations examiner want us to write on demand.
So you can't remove the spectator ions if it's a non-ionic equation.
Definitely. If it's a standard equation, you should never try to remove. You should never try to remove the spectator ions that can cause a serious problem. Now, can you bring your paper 1 and paper 2 book? Can you bring your paper 2 book?
Okay.
I'm sorry, paper 4. Can you bring your paper 4 book?
Okay.
Page 7.
Okay. I got it.
Okay. I have meanwhile opened a question. Actually, MCQ matching is also possible. Have you brought both the books or you brought only paper 4?
Good.
Okay, good. So can you open the, just a minute. Can you look at the question on the screen? And this is question, which statement about the periodic table is correct? Most metallic elements are on the left.
Yeah, I
Elements
think it's
in the
A.
same.
It can be A.
Hmm. It can be A because normally metals are on the left side. Elements in the same period have the same number of outer electrons. This is wrong. Why this is wrong? This is wrong because in the same period, they have the same number of shells. Elements on the left are usually gases. This is wrong because normally they are not gases. Normally they are solids. The relative
What
atomic
are
mass of
periods
the
again?
hmm,
Period is vertical or horizontal?
period is horizontal. Like if you draw like this, okay, this is a group and This is a period.
Also, if it was
So,
group, then it would be correct.
the relative atomic mass of the elements increases from right to left. Can you open your periodic table and you see that atomic number increases from right to left?
Yeah, it does.
Right to left.
Yes.
Are you sure? Because I think
Yeah.
you have to see again, because right, he's not saying left to right, he's saying right to left. So if you move right to left, you should see that.
The atomic mass, yes.
No, he says atomic number.
Atomic number or mass, because number then
Hmm?
wait, did he say increases or decreases?
He says increases.
Oh no, it's decreasing.
Yes.
From right to left, it decreases.
So he's trapping us, and look. So from left to right, if you notice, atomic number is increasing. So he's giving us a wrong answer, because actually atomic number, look at this screen. Now atomic number is wrong. Actually, it increases left. It can increase, but left to right.
This is atomic mass, not atomic number.
Both of them, left to right.
Yeah.
Atomic number is the smaller number. Look at this screen, Mikhail. Take it anyone. So for example, if I say scandium, look at this element. This is bigger number, mass number. This is atomic number. Look the atomic number.
Yeah. It's increasing from left to right, not right
Uh,
to left.
the bigger number is atomic number, and smaller number is mass. The bigger number is mass number. Smaller number is atomic number. Achha, now look at this. The letters are not the chemical symbols of the element. Which statement about the element is not correct?
You has two electrons. Two, 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 eight, two.
This is group 1, this is group 2, and this is group 3. Sorry, this is group 3, 4, 7, and this is group 8. Which statement about the element is not correct?
I think it's C.
Hmm?
C.
Yes, right answer. Why?
What's covalent bond again? Negative bond.
Hmm. Covalent bond is between a metal and a non-metal. He says
So
between
what is an
X
ionic bond?
is a covalent bond is between a non-metal and a non-metal. Ionic bond is
Yeah.
between metal and non-metal. So XY4 means that group 4 and group 4 and 7. So this is possible.
So group 4 is a metal?
Group 4 is not a metal. Group 4, you can look at the periodic table always and make a habit of looking it again and again. Look, this is group 4. This is group 4. Carbon, silicon, germanium, they are non-metal. tin is a metal, lead is a metal. These two are metals.
So why is it incorrect?
He says, actually, look, he says in the question, this one, why, which part?
Why is C incorrect?
So C is correct because X and Y, X is located at a higher position, Y is located on the second position. Can you tell me who is Y from the periodic table?
For silicon.
Silicon. And who is X?
Fluorine.
Fluorine. So they can merge, group 4 and group 7 can merge and they can form XY4. X is the element which is coming as fluorine and silicon is coming from the second element. So group 4 and they both are non-metal. Boron, carbon, silicon, both are non-metal. Halogen group number 7 is also a non-metal. Non-metal, non-metal, first point, and then non-metal with non-metal with non-metal.
So what? So it's true.
So C is right now. Acha, he say not correct. So why it's a problem? Non-metal, not. I got your question now. I'm sorry, I was not getting that. Actually, you are asking in this respect that what happened, why it's wrong. The problem is 4. Let me show you the problem. The problem is 4.
So can you write the bond? Can you write it fluorine plus
Make a
silicon?
bond. Fluorine, look, do you remember what's the meaning of 4?
No. Oh,
You know,
so that means silicon has to have a
silicon
has to have a
XY4.
charge
Actually,
of 4.
it look, for example, Y is silicon and X, let's say Y is silicon and X is fluorine. It can be SiF4, but he is saying F, basically he's saying Y4. So he want to have F XY4 fluorine and silicon 4. This is wrong. This is right.
So such small details.
Yes, this is chemistry. Actually, you know why? Because group 4 means it can make 4 bonds. Group 7 can make 1 bond. Numbers are crossed. So how it is possible that one halogen can bond with 4 group 4 members? Reverse is possible.
Okay.
A group 1 metal, lithium, sodium, or potassium is reacted with a group 7 metal, chlorine, bromine, and iodine, which compound is formed when the group 1 metal of which compound is formed when the group 1 metal of highest density react with the group 7 element of lowest density. Can you tell me group 1 members, please? Lithium, potassium, lithium.
Lithium,
Can you tell me
potassium,
from the
sodium.
periodic table? Please tell me group 1.
Lithium, sodium, potassium,
Lithium,
rubidium.
sodium, and potassium. I don't go below that because I need this list. Acha, in group 1, if I go down density,
Density increases.
if I go down density in group 1 decreases. Acha, can you tell me group 7?
Chlorine, bromine.
Chlorine, bromine, iodine. Acha, in this group, if I go down density
Wait, group 1 density decreases, I thought it increases.
Yes, these chapters which we are doing right now, which is called inorganic chemistry. Inorganic chemistry is totally related with memory. Now select the answer.
D.
He says group 1 metal of highest density and group 7 of lowest density. So in group 1, what element you are selecting group 1?
As
I will cancel
lithium.
A and D.
Huh? Group 1 metal of highest density. So lithium.
Sorry, group 1 metal, I'm sorry, group 1 metal of highest density react with group 7 element of lowest density. Sorry. So what should be the answer? If I take lithium here,
Group 1 of the highest density. So highest density. So lithium. And then
lithium from group 1.
group 7 lowest density. It
Hmm.
increases. Fluoride. It's supposed to be lithium fluoride, but
But
there's no
it's not an
fluoride. So
option.
chloride, lithium chloride.
Hmm. Metal X react with non-metal Y to form an ionic compound with the formula X2Y. X2Y means actually if I cross the
X
numbers,
is 1 and Y is 2.
X is +1 and Y is -2, which further means that this is a metal and this is
Non-metal.
a non-metal.
Group 6.
So now
X is in group 1. Y is in group 6. 1 and 3.
X is in group 1 of the period. That makes sense. That makes sense. X is in group 2 of 2 is possible, but 1 and 2 is not an option.
1 and 3.
Y is in group 6. But why not? Then the number comes in, na? -2. If X is in group 2, it will take +2. Here it will take +1. Group 6 means Y will take -2. And here it will take -1. So according to that, A is the right answer. Now,
Covalent compound. So non-metallic. R is non-metallic. And it's in group 7. I think the answer is D.
Acha.
Covalent is non-metal, non-metal. So R is
R2Si,
a non-metal.
a covalent compound with silicon, which diagram describes R? It's a covalent structure.
So non-metal.
Most closely, it should be a non-metal. So what about C and D?
Now, which group is it in? Because SI has not gained anything.
No, but how we decide? It's because it's a covalent. So we put the oxidation numbers R2 Si.
R is
We do not know numbers because we know that they are, but we know silicon. We know
is 2.
silicon is -4, so it should be. There are two of them, so it should be +4 also. So R is something which is coming from. R is something which is coming. So R is something with an oxidation state of +2.
No, but it says
Basically group
R2
4.
SI is formed. It shouldn't
Mhm.
be R is 1, SI is 2.
No, but that is for ionic compound. Now. This is not an ionic compound, it's a covalent compound. Remember, we were doing ionic equations just few minutes in the start of the class. So the
How is it
answer,
+4 -4?
because silicon is -4, no? Silicon is by
Group
default,
4.
silicon takes 4 charge. So it is group 6. Group 6 means it can take a valency of 2. It can take an oxidation state of 2. Acha, make this clear, Mikhail, that you do not cross the numbers. You do not cross the numbers in covalent compounds. Crossing the number is for ionic compounds. You use oxidation numbers for covalent compounds. Consider, you should consider oxidation. You should consider oxidation state. Okay, so we are stopping here. We have to, this topic is partially completed. We missed a class on Saturday because of the time clash I'm having. Can we put a class tomorrow around 4 o'clock UAE time?
Yes.
So I will try to put, inshallah, confirm it also. And we will, because we actually Saturday is clashing. We need to find a permanent because otherwise this is in these months, a lot of pressure is there. So we will do inshallah class tomorrow,
So
Monday, inshallah, around 4 o'clock UAE time, inshallah. Okay, but I will.
I have one question.
Hmm.
Why is SI -4? Because it's in group 4, so can't it be +4 also?
This is a very good question. Again, Mikhail, this is oxidation number. I will explain it again. Look, oxidation number is nothing to worry about plus and minus. It depends upon who is being attached. Actually, shouldn't worry about +4, -4. Look, I change it for the sake of argument. It doesn't matter. Look, make it -4 and make it +4. That's fine. In covalent compound, this is not a problem because they're not losing electron, they're not losing or gaining electron. A covalent bond is made by sharing. Acha, +4, -4 really does when you make a ionic compound. I shifted it, to avoid any confusion. And now I think you will not be confused. Silicon is in group 4. It should have a +4 and R is in group 6. So it should have a -2. And actually 2 and +2, -2 doesn't matter. But I have
So
shifted
can't
it.
it be group? Why can't the answer be C also?
No, but C means group 2. How you can find a non-metal in group 2?
Oh, okay.
Make a quick memory. Group 1 metal, full metal. Group 2 full metal.
Okay, got it clear.
Okay. So we are stopping here and we will inshallah continue in our next class tomorrow, inshallah. Okay.
Okay, love it.
Thank you. Allah Hafiz.